Okay, welcome to this first video tuition lesson on trigonometry. We're going to start by looking at some of the very basic definitions that you need to know about in trigonometry, and let's get started. Okay, the very first thing, if you want to use the ideas of trigonometry, you must have a right-angled triangle. This is the absolute must. If the triangle is not got a right angle in it, you cannot use trigonometry. Alright, here I've drawn a right angle triangle. It's a right angle triangle because here in the corner is marked the right angle, and as you should know by now, a right angle is 90 degrees, so that's a typical right angle triangle. However, sometimes in exams what they do is they change the position of the right angles to try and see if you can spot the right angle triangle. Here I've got 4 triangles turned in different positions, but they are all right angle triangles because they've all got the 90-degree angle in one of the corners. Sometimes they describe situations in which you can imagine a right angle triangle. Here, for example, I've got somebody in the water at a distance from the base of a cliff. This is a vertical cliff, and if you take a line from the top of the cliff to the person, this must make a right angle, and you could use trigonometry in a right angle like that. In this next little sketch, I have drawn a flagpole held in position with a support cable standing on horizontal ground. If it's on horizontal ground and the flagpole is described as vertical, then this angle must be a 90-degree angle or a right angle, and again you have a right angle triangle and you could use trigonometry on that. Now there are 2 things you really need to be clear about, you really need to understand if you want to get to grips with trigonometry, and here they are. You must understand what the opposite side to an angle means, and you must understand what the adjacent side to an angle means. Okay, there are 2 fundamentally important things you need to know if you want to use trigonometry successfully. Okay, let's start by looking at what we mean by opposite side. Well, the opposite side to any angle is the side that does not make the angle. Well, let me explain what that means by reference to these 2 diagrams. Here I have shaded in this red angle here. This red angle is made by that side and that side. Okay, here this red angle is made by that side and that side. Now the side which is opposite to this angle is this side there. This red length, this red side, is right opposite that red angle. Same here, this red angle, the side opposite to it is down here. It's this red length here. These red sides there and there, they don't make the angles, they are the blue sides that make the angles. Excuse me. The important thing to remember is that this is opposite. This is what we mean by the side which is opposite to the angle. Okay? What about the word adjacent? Okay, now the word adjacent is just a technical or a fancy name that really means next to or alongside, and I'll show you what that means with reference to these 2 angles here. Here I've shaded in this angle in red, and if you look at which side is alongside this angle, I've highlighted this one in red. This is the side alongside that angle there. I have not done this side This is not alongside that angle. It really is, but this long side in a right angle triangle has got a very special name, and I'll be coming to that in 1 second. Here in this angle, in this triangle here, this angle, this red angle, the side alongside it is this one here. So a side that is adjacent to an angle is one of the sides that makes the angle, but it is not this long side, which is called the hypotenuse. This side and the hypotenuse makes that angle, but the adjacent to this is this one, not the hypotenuse. Similarly with this one, the hypotenuse is there, that long one there, and that is the adjacent to that angle there, this one. So what is a hypotenuse? Well, the hypotenuse is always the longest side in a right angle triangle, and it's the side which is opposite to the right angle. Okay? This is the longest side, and it's opposite to that right angle there. Simple as that. Okay. Now, for every right angle triangle, there are only 3 trigonometric ratios you need to know about. Now this word ratios really means a division. Excuse me. It's a division between 2 lengths. And these lengths are the lengths of sides in the right angle triangle. Trigonometric just means related to trigonometry. Don't worry about the meaning of these 2 things. It will come apparent in a second. But there are only 3 trigonometric ratios that you need to know about, and they are sine, cosine and tangent. Okay, let's get straight into looking how sine is defined. Okay, in the right angle triangle below, okay, here, I've said let A be the angle at corner A. Now the way sine is defined for this angle is the following. We say the sine of the angle at A is equal to this ratio here. It's equal to the length of the side which is opposite to the angle A divided by, that's what this long line means here, divided by the length of the hypotenuse. So if we look at the triangle, we can see that the length of the side which is opposite to the angle A, well there's the side which is opposite to this angle here, so it's the length of this side divided by the length of the hypotenuse. Well, the hypotenuse is this one here, the one which is opposite the right angle. So the length of this hypotenuse is what goes on the bottom of this ratio. The length of this side which is opposite angle A is what goes on top of the ratio. And normally we don't bother to write lots of stuff like this. We usually abbreviate that as the following. We write, let's get that in position, we write that the sine of the angle A is equal to BC. If I put the triangle back in position, there we are, you can see what I'm talking about. We say the sine of the angle A is the length of the side opposite BC divided by AB, the hypotenuse. Here it is here, the opposite divided by the hypotenuse. This means the length of the opposite side divided by the length of the hypotenuse side. Now, had we instead chosen to, if I can get that into the right place, there we are. Had we chosen instead to take the sine of the angle at B, at this corner down here, then the ratio would have changed. How would it have changed? Well, it would have changed and looked like this. We would have said that the sine of the angle at B is equal to the length of the side opposite to the angle B divided by the length of the hypotenuse. Well, where is the side opposite to angle B? Well, clearly it's that one. So the length of this side would have gone on the top of this ratio, and the length of the hypotenuse, the longest side, which is opposite the right angle, this one there, AB, that would have gone on the bottom of this ratio here. Using letters, it would have looked something like this. Sine B is equal to AC, the opposite side, divided by AB, the length of the hypotenuse. By the way, when we write the sine of the angle at B, this little phrase is usually abbreviated to sine B, like that. Some people say sin B, but I prefer sine. Sine B is all of that phrase, just abbreviated. But the most important thing is to realize that if it's sine, then it's the ratio of the opposite to the hypotenuse. In other words, the length of the opposite side divided by the length of the hypotenuse. Okay, now let's look at how cosine is defined. Okay, let's get it in position. There we are. Okay, now cosine is slightly different. Let's see how. In the right angle triangle below, let A be the angle at the corner A, and let B be the angle at corner B. Now I haven't put B on this diagram because I've drawn a separate diagram, which you'll see in a second. But let's just concentrate our attention on the angle here, A. Well, how is the cosine of this angle defined? Well, here it is here. We write that the cosine of the angle A is equal to the length of the side adjacent to the angle A divided by the length of the hypotenuse. Alright, so which is the side adjacent to this angle here? Well, it's not the longest side, because that's the hypotenuse. It's the other side. It's this side here. This is alongside angle A. So it's the length of this side goes on the top of the ratio, and the length of the hypotenuse goes on the bottom of this ratio. And we usually write that in this manner. Again, cosine of angle A gets abbreviated to cos A. There's no need to write all that out. Just write cos A is equal to the adjacent side, AC, divided by AB, the length of the hypotenuse. So in other words, cosine is now adjacent divided by hypotenuse, or the length of the adjacent side divided by the length of the hypotenuse. That's how cosine is defined. Now let's look at angle B in the same triangle and see how the cosine ratio would have changed. Okay, so had we chosen to take the cosine of angle B, then the ratio now would have looked like this. Okay, the cosine of the angle at B is equal to the length of the side adjacent to angle B divided by the length of the hypotenuse. Okay, which is the side which is adjacent or alongside B? There's B. It must be this one. That is the side adjacent to angle B, and this side is the hypotenuse. So cosine for angle B is the length of that side, which goes on the top of the ratio, divided by the length of this hypotenuse, which would go on the bottom of the ratio. And this normally gets abbreviated to that. We write cos B is equal to BC, the adjacent side, divided by AB, the hypotenuse, or in other words, cosine is adjacent divided by hypotenuse. the length of the adjacent side divided by the length of the hypotenuse. Okay, now let's move on to seeing how tangent is defined. Let's get that in the right place. There we are. Again, in the right angle triangle here, let A be the angle at corner A. Let B be the angle at corner B. I haven't drawn that on this diagram, it's on a separate one, which you'll see in a second. Okay, let's concentrate our attention on this angle here. We want to know how is the tangent of angle A defined. Right, this is how it's done. We write that the tangent of the angle A is equal to the length of the side opposite to the angle A, all divided by the length of the side adjacent to the angle A. Okay, let's see which sides are which. The length of the side opposite to angle A. Well, the length of the side opposite, there's the side here opposite to the angle A, so it's the length of BC, and it's divided by the length of the side adjacent to angle A. Well, that's the side adjacent to angle A. So the length of that side goes on the bottom of the ratio, the length of this side goes on the top of the ratio. And in shortened form, we would write all of this tangent of the angle A as tan A is equal to BC, here it is, BC, the opposite, divided by AC, there it is, the adjacent. The important thing to remember is that the tan of any angle is the opposite divided by the adjacent. This is the length of the opposite side divided by the length of the adjacent. Now let's look at how the tangent ratio would have changed had we taken the tan of angle B. So, had we chosen to take the tangent of angle B, then the ratio would have looked something like this. Okay, here it is here. We would have written that the tangent of the angle B is equal to the length of the side opposite to the angle B divided by the length of the side adjacent to the angle B. Well, the side which is opposite to this angle here is this one, AC. So the length of this AC would have gone on the top of that ratio, and the length of the side adjacent to the angle B, well, it's obviously this side here. So the length of that side would have gone on the bottom of that ratio. And that's usually abbreviated to that. The tangent of the angle B is written as tan B, and it's equal to AC divided by BC, or the length of the side opposite to the angle B divided by the length of the side adjacent to angle B. Okay, now I've written those down in a sort of shortened form. There they are, and there's no getting away from the fact that you really just have to know these three ratios, how these three ratios are put together. The sine of any angle is always the length of the side opposite to the angle divided by the hypotenuse. The cosine of any angle is the length of the side adjacent to the angle divided by the hypotenuse, and the tangent of any angle is the length of the opposite side divided by the length of the adjacent side to the angle. Okay, let's see now how this is used in some examples. We are going to look at how we find some sides in a triangle, a right angle triangle. First of all, you need to know one angle and the length of one side. If you know the length of an angle and the length of one side, then you can find the lengths of the other sides. Okay, and this is how you would do it. Let's look at example 1. Now, before I launch into this example, let me just explain a few things. Normally in GCSE questions they describe the situation as I have done here and ask you to find something. They usually give you a diagram that also illustrates this situation. They do not have to do that. So it is a very good practice to see if you can, from the description here, imagine what the right-angled triangle might look like. Okay, I'll read it out and see if you can imagine what the situation would look like if you did a sketch. I'll show you the diagram that I've got in a second. Anyway, it says the diagram below shows a vertical flagpole standing on horizontal ground. From the top of the flagpole, the support cable is stretched to the ground and fixed in a position at a distance of 10 meters from the base of the flagpole. The cable makes an angle of 57 degrees to the horizontal ground. Calculate the height of the flagpole and the length of the support cable. Okay, the diagram should look something like this. There is the flagpole. There is the horizontal ground. Here is the support cable from the top of the flagpole to the ground, making an angle of 57 degrees to the horizontal ground, and it's fixed in the ground at a distance of 10 meters from the base of the flagpole. Now I have called the height of the flagpole h, which is what we're being asked to find. We do not know this length h, we're being asked to find it. Well, we've got one angle, we know the length of one side, we can use trigonometry. Oh, but is it a right angle? It describes this as a vertical flagpole. It describes this as horizontal ground. So that must be a 90-degree angle, and yes, we can use trigonometry. Well, this is how. What I normally do is I write down the information we have got. Let me put the diagram back so that you can see what I'm referring to. What we can do is to write down what the h's and the 10 meters mean. H is the length of the side which is opposite to the angle 57 degrees. As you can see, this height of the flagpole is indeed opposite to the angle 57 degrees. And the 10 meters is the length of the side which is adjacent to this angle. It's alongside this angle. Well, look at the words we've got here. Opposite, adjacent. There is only one ratio that uses the lengths of these two sides, and that's the tangent. So we would put into this the following. We would say, the tangent of 57 degrees must be equal to the opposite divided by the adjacent. What do I mean? I mean the length of the opposite side to 57 degrees divided by the length of the adjacent side to 57 degrees. Well, when I put in the information I've been given, this is h and this is 10 meters. Now you have here what's called a very simple trigonometric equation. In other words, an equation involving trigonometry. It's very easy to solve. There are no tricks involved, and I will show you how to do it right now. The first thing you will need to do is to use your calculator to find the decimal form of 57 degrees. So you put in 57 degrees, find the tangent of it, and out would come this long decimal here. You could write it out to so many decimal places, and you can round it up later at the end. Well, we've got this on the left hand side of the equation, but we've also got this awkward looking fraction on the right hand side of the equation. No matter, if we've got a ratio like this, we have a number on the bottom. Well, how do we get rid of this fraction? How would we get rid of this 10? we would multiply both sides by 10 and cancel the 10 there with this 10 on the bottom. Another way of doing it is called cross-multiplying, which is basically the same thing. The number on the bottom here can be multiplied across the equal side with the number on the top on the other side of the equation. It's called cross-multiplication. It's not taught much these days, but it's just as effective, and it's a little bit quicker if you know what you're doing than multiplying both sides by 10 and cancelling the 10. Okay, so once you've got the tan of 57 degrees in its decimal form, you can then multiply across the 10, leaving you with h as the subject of the equation. And of course, if you're multiplying by 10, this decimal point will be moving one place to the right, giving you the final answer of 57.398649, which approximates to one decimal place to 15.4 meters. Okay, now let us find the length of the cable in this problem. Again, I've drawn a diagram, and I don't want you to see that bit just yet because I want to talk about the diagram. So here we go. So what I've done is I have called the length of the cable C. I don't know what it is, we'll call it C. This here is 10 meters, and this is the length of the cable. We write down what we know about C and C and 10 in this manner. Well, 10 meters is the length of the side adjacent to that 57 degree angle, just as it was before. This time C is the length of the hypotenuse. Okay, so just look at what we've got here. These two words, we've got the words adjacent and hypotenuse. Well, there is only one ratio that uses the lengths of the adjacent and the lengths of the hypotenuse, and there it is, as you can see, the cosine. Okay, so we would write the cosine of angle 57 degrees is equal to the length of the adjacent side divided by the length of the hypotenuse. The length of the hypotenuse is this length of the cable, which we do not yet know. Okay, so we would again make this trigonometric equation, very simple trigonometric equation. Here it is. We would write the cosine of 57 is equal to 10 divided by C, the length of the cable, the hypotenuse, and that's the length of the adjacent side. Again, I'm going to use what's called cross multiplication, and here it is here. Cross multiplication allows me to do it in one step. I have taken the C, which is on the bottom, multiplied it up here, and I've multiplied the cos 57 down underneath the 10. Okay? In other words, in one step I have made C the subject of the equation. And the next step is to use your calculator to find the cosine of 57 degrees. And in decimal form, that is the following: 0.544639. We divide this into 10, and out comes our answer 18.36078646, which to one decimal place is 18.4. So that is the length of the support cable. Now let's look at another example, and again I will describe the situation and see if you can sketch the right angle triangle that is hidden in this description. As I said before, sometimes they give you questions like this in exams and they leave you to do the diagram, so this is good practice. Okay, let's look at example 2. A jumbo jet J is flying on a bearing of 033 degrees towards an airport A. The distance between the jet and the airport is 156 kilometers. A city C is both due west of the airport and due north of the jumbo jet. How far is the city from the airport? Good. Now the diagram should look something like this. There's the jumbo jet J, there's the airport A, there's the city C, and there is the distance between the jumbo jet and the airport as 156 kilometers. Now, because the jumbo jet is flying on a bearing of 033 degrees, bearings, as you should know, are measured from north clockwise, like that, which is why there is an arrow on this angle here. So this angle in here is 33 degrees. Now, because the city is both due north of the jumbo jet and it's due west of the airport, this means that this angle in here is a 90-degree angle. So we've got the length of one side, we've got an angle, and we've got a right-angled triangle. So yes, we can use trigonometry. And here's how. If I move that up there, and hopefully I'll get the important bit underneath. Yes, there we go. Let's write down what these sides are. Well, CA is the length of the side which is opposite to the angle. There's the angle, there's the side opposite to this angle. So CA is the length of the side opposite to the angle of 33 degrees, and the 156 kilometers is the length of the hypotenuse. There's the hypotenuse, the longest side in the right-angled triangle. Well, look at what we have. We have opposite and we have hypotenuse. Well, there is only one ratio that uses the lengths of the opposite and the hypotenuse, and that is sine. Okay? So we would write immediately that the sine of the angle at 33 degrees, if I can get the diagram, can't quite manage it, there we are, we would say that the sine of this angle here is equal to the length of the opposite side divided by the length of the hypotenuse, or in other words, we would make the trigonometric equation there. We would say the sine of 33 degrees is equal to CA, the length opposite to the angle, divided by 156 kilometers, which is the length of the hypotenuse, like that. Okay, so now our only problem is how to solve this equation, and here's how we do it. We again want to make CA the subject of the equation. I could multiply both sides by 156 and cancel that 156 with the 156 up here. This is the same thing. I have cross-multiplied the bottom of this ratio across the equal side with the top of the other side of the equation. With my calculator, well, it would look like that, rewritten, with CA as the subject of the equation. With my calculator, I would now need to find in decimal form the sine of 33 degrees, and it comes out as 0.544639 multiplied by 156. Do the multiplication, there is the full form of the answer, which to the nearest kilometre is 85 kilometres. So we've found that the airport and the city are 85 kilometres apart. Now another very nice example, which I found in a book, or I've rewritten for myself, is the example 3. It drew a triangle, there it is, like that, and it asked the very simple question, why would the triangle below be impossible to draw. Well, let's look at what we've got. We've got a right angle triangle. We've got the length of this side as 6 centimeters. We've got the length of this side as 15 centimeters. And we are told that this angle is 46 degrees. Okay, well, let's look at what the sides of the triangle actually are. How are they related to the angle that's there? Well, there's the same situation. That's the 6, that's the 15, that's the angle 46 degrees. There's the right angle, just as before. Well, what is the 6? What is this side? The 6 centimeters is the length of the side opposite to 46 degrees. Yes, if you look at that, there's the side opposite to this angle. And the 15 centimeters is the side adjacent to the angle 46 degrees. There's the angle 46 degrees. There it is. 15 centimeters is the length of the side adjacent to that angle. Okay, so what have we got? Oh, we've got opposite, we've got adjacent. Well, there's only one ratio, trigonometric ratio, that uses the length of the opposite and the length of the adjacent, and that is tangent. So immediately we can write the following equation. We can say that the tangent of 46 degrees is equal to the length of the opposite side divided by the length of the adjacent side. Well, that is 6 divided by 15. That comes out on your calculator to 0.4. Now, your calculator will show you that excuse me, that the tangent of 46 degrees is 1.03553. In other words, it's not 0.4. Now, because these two answers are different, this shows that the right angle triangle with the lengths and angles shown above is impossible to draw. So in other words, the tangent of the angle is really equal to that. When you divide the two lengths of the triangle given, they come to 0.4. These two decimals do not match, and because they are different, it shows that that triangle which has been given to you is impossible to draw. Okay, I hope you have learnt something about the basic ideas of trigonometry in this lesson. There are other lessons to do with trigonometry that proceed on from this lesson. Okay, thank you very much for listening.